So dear students, last time we have studied about the solubility of solid and gas in a liquid. Let's relate one. Today we will study about one of the greatest law of all time, that is Henry's law for solution of gases in liquid. Okay, so Henry was the first to give the quantitative relation between pressure and solubility of a gas in a solvent, which is known as Henry's law. Now, this is what the Henry's law. What does he says? He says that he states that the solubility of a gas. He says the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid, present above the surface of liquid or solution. You can say solution also. This was given by Henry. It means he says the small solution is directly proportional to the partial pressure, the pressure which is exerted by the gas. Suppose this is a solution where I'm going to use a black dot for the gaseous molecule which is dissolved over here, and the pressure exerted by the gas over here. Okay, so this is the pressure exerted by the gas on the surface and is directly proportional to the solubility. Means whatever the solubility, if you increase the pressure, the solubility will definitely increases. So this was the same thing at that time. Contemporary मतलब क्या होता है कि during the same time when the Henry was alive, Dalton was also alive. So that he says that, what does he say? He considered this solubility as a mole fraction. He said that the mole fraction of gas in the solution is proportional to the partial pressure of the gas, and that's why what he says mole fraction directly proportional to the partial pressure of the gas. This is what given by him, and that's why the most commonly both of them are same, because solubility and mole fraction is also one kind of measurement or concentration expression of unit of the liquid or a solution, whatever that we said. So the same thing he says, and that's why most of the time what you are supposed to write the Henry's law is this. This is the law which you are supposed to write when they ask write or state Henry's law in exam. It will be a 3-mark question, can be asked for you. Okay, state the Henry's law and write its uses. So what are this one? He says that the law is now commonly considered as the partial pressure of the gas, in vapor phase, is proportional to the mole fraction, So students, you have to write down this in the book. Exercise answer, whatever that it is given, you have to write down this statement. Okay, now this statement, let us write down the statement. Mathematical form. The partial pressure is P, directly proportional to X. Now this is what? So to remove the proportionality sign, they have given a must constant, and this constant KH is called Henry's constant. And this is different for all different gases, and even at the same gas it is different at a different temperature, which is evident in the table number 2.2 in your textbook. Okay, so what exactly happened here? The temperature is very important. The KH value of nitrogen and oxygen increases with the increase in the temperature indicate that the solubility increases with the decrease in the temperature. Okay, so what happened, the if the increase in the temperature increase in the temperature, that what happened, if the temperature is increasing, what happened, then the solubility of gas will decrease if the temperature increases with the decrease in the temperature. Yani solubility is always decreasing when you increase the temperature, which we have already studied about it, and I also explained you at that time why during the winter season, okay, or during the any season, the aquatic animal goes in the deeper one. Why? Because that is the temperature where it is cool temperature and where the dissolution of gases is more. So this is what we have to understand about this. Up to this one you will write, you will get 1 mark for that. Now then we have its uses, the 3 uses given over here. The one of that, to increase the solubility of CO2 in the aerated drinks and soda water which is sealed under a high pressure. As you know, more the pressure you will give, the carbon dioxide is going to be dissolved more, and it is going to be useful for this. Henry's law can be applied in this one in industry, and this is what, and as one of the biological, there are 2 biological phenomena which we are going to talk about now where this law is applicable. Biological phenomenon, one is band and one is anoxia. Okay, what is band exactly? Let us understand. The people, those who are playing cricket, football, any sports, will knowing this. What is band means, what happens, a cramp comes in your legs. Okay, sometimes you have a cramp in your hamstrings. Okay, hamstrings, that is below the what are that we can say under the thigh muscles, which is considered as in hamstrings. It pull down or pulls up. What happened exactly that? So it's like a process where what happened, we have a small capillaries, okay, in our body. Scuba diver, let's take an example of a scuba diver. When they goes inside, as we know, when we go deeper and deeper and deeper into the sea, pressure increases. What happened, when a pressure increase, the solubility of gas will also increase. Why? How it is said? It is extended over here that pressure is directly proportional to the mole fraction, and mole fraction is nothing but solubility. So solubility of gases increases. So when a scuba diver goes inside while breathing, gases dissolved gases while breathing air at the high pressure underwater. Increased pressure increases the solubility of atmospheric gases in the blood. Now in this blood we got, along with oxygen, nitrogen do come. Okay, so nitrogen will also, when divers comes towards surface, now from there when it is coming up, what exactly happened, when the diver is coming up, then this nitrogen forms bubble, this forms bubbles, and these bubbles are so small and tiny which blocks capillaries, block capillaries. Guys, this is very important. When the capillaries are blocked, then what happens? It gets cramped, and that pain is that creates an enormous amount of pain, and this condition is known as bands. This is known as bands. So what happened, to avoid band, what divers use, scuba divers use, they use a breathing tank. They take along with a breathing tank. Now in this breathing tank, what does they have? They have a mixture of oxygen, helium and nitrogen. Guys, this percentage you have to keep it in your mind. Oxygen is 32.1%, helium is 11.7%, and nitrogen is 56.2%. So what happens, whenever he is taking breathing that air, this mixture over there, already he has nitrogen. So when he is coming out, this nitrogen doesn't goes out. Whenever the dissolved nitrogen which comes from the atmosphere goes up, okay, so get diluted, okay, with that, and that's why the toxic effect of nitrogen in the blood can be avoided. This can be avoided. So this is one phenomena where a loop, where the solubility of gas, means Henry's law, is applicable. So this is the one, scuba divers using what we can say breathing tank along with them. Okay, and at a higher altitude, the another anoxia takes place. What happens as in when we go higher, that oxygen at a higher level, at above sea level, its concentration is less. So this leads to the low concentration of oxygen in the blood and tissues of people living at high altitude. Okay, so low blood causes climbers to become weak and they are not able to think properly. Clearly, symptoms of condition that is what called anoxia. So a proper amount of oxygen is not available and that's why they are not able to think properly. So what happened here also they use climbers, those who are there, they can also use this drivers when divers breathing tank where they can apply this thing. Why? Because they can get a sufficient amount of oxygen to the body and the blood and the tissues, and that's why they will not come across the anoxia. So guys, this is the one which we have to learn. Okay, so they can ask you a question. Now let's have a numerical which is given in our textbook. Solved example number 2.4. Now in the 2.4, which is exactly example 2.4, is related to our Henry's law. So what is given over here? Nitrogen gas. I'm not going to write a question over here. You have to understand the question. You can read it out, that question over there. If nitrogen gas is bubbled through water at 293 Kelvin temperature, how many millimoles of nitrogen gas dissolved in 1 liter of water? Assume that nitrogen exerts a partial pressure of 0.0987 bar. Given that Henry's law constant is N2 at 293 Kelvin is 76.48 kilobar. So, dear students, I need to find how many millimoles of that. But what is my formula? My formula says this is partial pressure of N2. Okay, this is CO2. Sorry, I am not going to write down the CO2. The formula X N2. Mole fraction of nitrogen. I need what? Moles. So moles find करने માટે, as we know, the mole fraction can lead me to go there. So the partial pressure is already given. What is the partial pressure given to us? 0.987 bar. Okay, and what about the KH? Henry's constant is given 76.48 kilobar. So dear students, it should be only in a bar. So to remove kilo, I can write it down. It's multiplied by 10 raised to 3 bar. Understand? So this is what exactly happened over here. So now dear students, let us understand substituting the value. Let's find it out the number of mole fraction of this. So what will be the mole fraction? So according to this, the formula can be modified in this way. Substituting the values over here, the pressure is 0.987 divided by 76.48 into 10 to the power 3. I will get an answer which is 1.29 into 10 to the power minus 5. Okay, it will be minus 5. So dear students, this is what we have to understand. Clearly, it's very clear. This is the mole fraction of nitrogen. Now the mole fraction of nitrogen requires another thing. What is it? This is, they say the water is dissolved, and water is the amount of gas is 1 liter. So number of moles of H2O, how can I find out number of moles of H2O? The number of moles of H2O can be found by 1 liter, it's like 1000 gram we will assume, divided by 18 will give me 55.55 mole. Okay, I'm going to write down 55.5 moles. That is water. Now let's see the formula for mole fraction of nitrogen. It means number of moles of nitrogen divided by total number of moles of water plus number of moles of nitrogen. Here you can see the number of moles of water is very high. So you can write down here number of moles of water is very high than number of moles of nitrogen. Therefore, this is neglected. Therefore, I can write down the equation like this. Therefore, X of N2 is equals to N of N2 divided by N of H2O. Clear? So what is number of moles of nitrogen that I have to find it out? So I will write down it this way. Standardize karo. Then number of moles, mole fraction of nitrogen into number of moles of water. So what is mole fraction of nitrogen? 1.29 into 10 raised to minus 5. So this will be 1.29 into 10 raised to minus 5 multiplied by number of moles 5.5. Okay, so the answer will be 7.16 into 10 to the minus 4 mole. Okay, but they are asking about millimole. So 1 mole is equals to how many millimole? 10 raised to minus 3 millimole. Therefore, you have to just multiply this number with 10 raised to minus 3. So what will be the number of moles? So here that we have 7.16 into 10 raised to minus 4 is equals to how many millimoles? So 7.16 multiplied by 10 to the power minus 4 into 10 to the power minus 3 is equals to 10 to the power minus 4 minus 3. 1 mole is equals to 10 raised to plus 3, so 9 mole. Okay, so this will be plus 3. So multiply by 10 raised to 3. Milli 8 plus 10 3. Okay, fine. Milli multiple. Okay, so then what is that? This is millimeter. 10 raised to 3 meter. 10 raised to 3. 1 meter. So how many millimeter? This is 1 mole. So what is this? This is what we got it over here. It has to be multiplied by 1000. We have to multiply by 1000. So what do I have? I have a very nice thing. So what is the answer? The answer is 7.16 into 10 to the power minus 1. So the answer is 0.716 millimole. So guys, the same way you have to do the example given in text question 2.6 and 2.7.